Hey, how's it going? Welcome back to ThinkView, and this is NK. Many of my friends ask me which laptop or PC should I choose to run AI locally, whether I should choose Intel or AMD or Apple or like Nvidia. So today, I want to make a video that answers those questions and also explain most important thing you need to consider when choosing a computer for local AI. At the end, I will also recommend some configuration that I think really suits those people who start experimenting with local AI. Now, let's get started. The first thing I want to say is that you shouldn't pay much attention into the NPU. NPU is a chip that specializes with AI tasks and usually come with newer models today. And usually the chip is used for tasks like background removal, virtual lighting, or webcam effect. However, to take full advantage of an NPU, usually you will need a software that has been specialized designed or optimized the use of NPU. That software often comes from the chip manufacturer or an operating system company such as Microsoft or Apple. In practice, most of the workflow that we are interested in, like running the large language model or stable diffusion, generating audios, videos, or image, usually won't utilize the NPU. And to be fair, NPU is not that powerful enough to run those workflows either. Overall, I think that those NPU that comes with like 60 TOPS, 50 TOPS and rated for AI PC are just marketing buzzword. So, what should we pay attention to when we pick a PC or laptop that run AI locally? Well, the short answer is GPU. And most capable AI models are also quite large in size. So the important thing when choosing a GPU is how much memory that the GPU can access. Because if the model doesn't fit into the memory, it doesn't matter how powerful the GPU is. You may not be able to run the model at all. Even when the software supports offloading some part of the model into the system RAM, the performance can still drop significantly. For integrated GPU solutions such as the Intel Arc B390 or the Strix Halo with the Radeon 8060S, the GPU uses the shared system memory instead of dedicated VRAM. And because of the way that Windows work, even though that your system has up to 64GB of RAM, you can only allocate up to 48GB for graphics memory. Apple Silicon use unified memory, and because of the way that macOS handle things, you might have more VRAM for your GPU. For a system that has 64GB of memory, you can use up to around 60GB for GPU alone. Nvidia remains the safest option in terms of performance and software compatibility. Most AI models, open source projects, and custom nodes are developed for CUDA first. That means that if you download something from the internet, the chance to get it to run immediately on Nvidia GPU is still the highest. The downside of Nvidia GPU is that they are expensive, and also the memories are very limited. Mainstream laptop GPU only come with 8 or 12 gigs of VRAM. To get 16 or 24 gigs of VRAM, you normally need to buy a much more expensive machine. On desktop side, however, even an RTX 5090 with Nvidia fastest consumer GPU only come with 32 gigs of VRAM. It sounds a lot more than an average consumer GPU, but it still cannot run much with 32 gigs of VRAM. Especially when coming to large language model with long context windows, or maybe you host an AI agent yourself that needs several models loaded at the same time. The second thing that you should look after is memory bandwidth. In short, memory bandwidth is how fast the data transfer from the GPU to the memories. For large language model, the higher the bandwidth, the more token per second you get. So even if your GPU is very powerful in theory, low memory bandwidth can create a bottleneck. For example, in some large language model workflow, an M1 Pro MacBook Pro can compete with or even outperform a base M5 MacBook Pro during token generation. The M1 Pro has up to 200GB of memory bandwidth, while the base M5 has lower memory bandwidth. Also, this is the GPU and the bandwidth from those chips that I think very suited for people who want to learn how to do local AI. You can check it out here. Of course, the results in other workflows are depending on many factors, but this is just for you to see how important the memory bandwidth is. One laptop that I highly recommended for those who want to run AI locally but with low budget is the M1 Max MacBook Pro. It has up to 400GB of memory bandwidth and can be configured with up to 64GB of unified memory. And I actually have one right here. This is the MacBook that I use to run AI agent for months now. And thanks to its 65GB of RAM, I can run 2 to 3 agents at the same time without running out of memories. And a MacBook Pro with large pool of RAM are very useful to run mixture of expert models. These models can have a very large total of parameter count, so they require a lot of memory to store the expert weight. However, only a subset of those experts are activated for each token. This means that the amount of computation per token can be lower than that of a dense model with the same total number of parameters. And if you plan to run local AI for image or video generation, then you have to pay attention to the software backends. The backend is basically a software layer that allows the AI workflow to communicate with the GPU. Different manufacturers have their own backends. Nvidia is well known for their CUDA. Apple uses Metal, while AMD is primarily use ROCm, and Intel has their own OpenVINO. A chip may be very powerful on paper, but if the backend is not fully supported, well then the hardware is not fully utilized. On Apple Silicon, many language models can run well through MLX. A lot of AI software also use PyTorch, and as far as I can see, PyTorch also have a very good support for Apple GPU. This makes macOS is a very prominent platform for almost every AI workflow, from image generation to video generation to large language model or maybe transcription, voice generation. However, a Mac can still not replace Nvidia in every situation. Many open source AI projects are still developed for CUDA first. Some comfy UI custom node may only support CUDA only. Some workflow may run slowly on Metal or maybe require an alternative implementation or maybe not running at all. And if you don't want to use a Mac but you still need a large pool of VRAM, then you can consider Strix Halo. It's offered up to 256GB per second of memory bandwidth and is also available of configuration up to 128GB of RAM. The hardware is genuinely powerful and it can also handle modern AAA titles quite well. However, AMD still faces the same issues with backend. Although ROCm has evolved over time and to a point that I think that is very usable for basically every workflow, but it still has some problem here and there, and the maturity is not there yet if you compare to CUDA. So again, if you want to buy a Ryzen AI Max machine, then check for the software and the workflow that you're working on, whether it has the support on the AMD or not. With Intel Panther Lake, however, I don't really want to say that you shouldn't get this one for your local AI workflow. The new Panther Lake chip such as the Core Ultra X7 350AH has a fairly capable integrated GPU. Intel also has its own AI software ecosystem such as OpenVINO and OpenAPI. The main issue is that many community AI projects are not developed or tested for Intel GPU. They usually prioritize CUDA first, followed by Metal, ROCm, or other backends. So in order to get the best result for an Intel GPU, you may still need to experimenting, install alternative version, or maybe troubleshoot a lot. So for that reason, if I choose a laptop for local generative AI, well then Intel is not my go-to. That doesn't mean that Intel Panther Lake isn't good. It just means that Intel ecosystem need more time to mature and polishing itself. Of course, there is one mainstream option. It's the NVIDIA DGX Spark. It's a compact AI workstation built around the NVIDIA GB10 Grace Blackwell superchip. Its main advantage is that it combines the NVIDIA CUDA ecosystem with 128GB of unified memories. One of its downsides is that it costs you a fortune to actually own one. And it's also not supporting Windows also. It's running on NVIDIA OS, which is an Ubuntu-based operating system. I have seen that NVIDIA has introduced the RTX Spark, which is the alternative of the DGX Spark but for Windows. And whenever ThinkView has an RTX Spark hands-on, we definitely make a detailed test on that machine, especially for AI. Now, to sum it all up, if you don't have the budget for high-end NVIDIA laptop or PC, then the MacBook Pro that runs the M1 Max is the most valuable choice. But if you can build a desktop PC, then an option that's worth considering is the NVIDIA RTX 5060 Ti with 60GB of VRAM. This is the type of hardware that I have been using nearly a year now, and I have built tons and tons of things out of it. So, what else do you want to know about the local AI? Let me know in the comment section down below and I will answer them. Now, thanks for watching. This is NK from ThinkView and see you guys next time.